Hello everyone, welcome to this review of the Raku Solutions of task number 2, week 71. The task is called trimmed linked list, but actually it's not like trimming the list, it's just removing the element. You're given a singly linked list and the positive integer n. Write a script to remove the nth node from the end of the linked list and print the linked list. If n is greater than the size of the list, then remove the first node of the list. Please use pure linked list implementation. Right, so there's a list and I want to remove the first element from the end, and the first element from the end is number 5, so it's removed here. And so yeah, just a note that we have to count from 1, and if it's 5 or 6, then we just remove the first element as it's seen here. Right, so it's the task is this, and let's look at the solutions. Again, let me start with my solution first, because I really didn't like all those linked list trees and stuff and graphs tasks. They're interesting, but they're difficult. And okay, but nevertheless, so there's some input. I'm taking this n, I'm going to modify it for some reason, right, somewhere, so this is the n, this is the size of the list. It should be 10 by default, and okay, so and the rest is the body of the main function. So I really enjoyed using this unit submain construct. For a node item, I'm preparing this class. Actually, it's just a structure in terms of C. A class that has an object of this class has this data with some value, basically an integer value, and the pointer to the next value. And this is done readable and writable because I'm going to modify the list, right? Right. Then the first task is, subtask is to create the list of random integers. And I'm doing it just like this in one line. But the only thing is that this list is filled from the last element towards the first element. But there's no difference because if the elements are random, who cares? Right, so I'm just, because this code is easier, it's simpler because I only have to create this new, I only want to call this new constructor only once, not like first create the first element, then in this cycle append more elements. But nevertheless, so this is where we had this list at this point. We can print this, right, and head is pointing to the first element. Right, then, to be like really correct, we don't know, we have to assume that we don't know the lengths, right? So we have to count the elements and determine the lengths. So we just move from the head elements towards the end, and after that, we can count the elements. Okay, so then we have to, the main thing is to find the element to be removed from the list. So if n is big enough, we remove the first element and just set the head pointing to the second element in the list. So notice that we cannot delete, we do not delete the first element. So it's somewhere in memory without any link. So it's Raku's jobs to take care of this. And if the n is not that big, then what I want to do, I want basically to count from the beginning of the list and find the position which will correspond to the nth element from the end, right? We have to make small corrections because the last element is element number 1, not number 0. And then just because we need to count from the beginning, not from the end. And after that, just keep track of 2 elements, the current and the previous element, because we have to remove the element at the position n, and we have to take the pointer from the from its neighbor, right? So we need it. So both previous and current variables are modified on each iteration while we are going towards the end of the list. And in the end, we can just skip the element that was found, and here we go. So the element is removed. 2, right? So let me use the defaults. Right, so this is yeah, so the output is lazy lazy in the sense that I'm only using this say, but so this is the original array, this is the not array, list, this is the modified list. So I was going to remove the third element, so let's see. So 46 is there, 13 is there, 58 is there, but 88 is removed, and this 88 is number 1, 2, 3. And after that we have 73, 75, 0, and 17, and 21, and 58. Right, so the element number 3 is removed, and if I want to remove like the 10th element from the array of 3 elements, right, so there are 3 elements in the beginning, and there are only 2 elements in the end, and those 2 elements are the last elements of the original list. Right, so it seems a working solution. All right, so now let's look at other people solving this problem. Right, again, Ben Davis. Right, so wow, plus. What does this plus mean actually? So where? Oh my God! Oh, it's difficult. Oh, maybe if I will not forget, I will skip this until the end, and let's find a bit simpler solution. This one seems simpler. Okay, so main function takes this n variable, right, and some list, the slurpy parameter, so it will take all the other arguments into this list. So yeah, we're not generating list here, right? So we have to type it if I'm correct. Right, so right, build the list backwards again. So the list is built backwards and keep the root at the list. So head, current, and in loop we are creating the new node, and we're taking the value from the input list, and right, and set the next pointing to the current head, and repeat this procedure for all the elements from the list. Then compute the size of the list. Right, so again, so we have to yeah, so head.size. What is head.size? So we have to understand what this node is, right? Size of the list is this dot say head put. Right, so let's look at this class node. There's a value, there's next, also it's readable, writable, and there's the string method, and there's the size method. So the string obviously is used when you are, yeah, I forgot again. So when you use put, right, so say calls gist, method gist, and put uses the str method if it exists. Right, so current string, so yeah, basically we're just appending something to the string, and then we return the string. So basically right, so current value, then an error. If there's next, then we move to the next element and repeat it until we find the last element, which is nil. Right, and size is right, so yeah, it's an obvious thing. So it just counts, it just moves towards the end until the end is found, and it increments the counter, right, and returns it. So this size, right, just counts the number of elements in the linked list, right? And the linked list is the head of this list is in this $head, and right then, okay, so index to remove. So yeah, basically the size minus n plus 1, right? Particular case, remove the root. So if right, if n is big enough, what is index? Index to remove. Okay, so if it's the first element, wait. Index to remove the first. No, wait. So if index is 1, we have to remove the last element, right? So why we're skipping the head element? Or if n more than size, right? I'm not sure this is right. But we can check it. Remove a specific element, but not only if this has not been already done by removing the root element and thus changing the size of the list, right? So if size of the current list is size of the list, so if the list was not modified, but actually we can just use this if and else here, right? Then right, we start with the head element, and while we reach the end of the array of the list, what we're doing, so we're checking if we are in the correct position to remove the element, right? And just skip the next element, so the next neighbor is skipped, and the next after next becomes the next item, right? Some manipulations with index. Why do we need this? I believe we can just skip current next. Not quite sure what these lines are doing, but right, and then right. So I suggest we will not do try to understand every bit, because all the solutions are really big, something like that, and I don't want to spend too much time on this. Raku 2. So what we need, right? So we need to input n, the element to remove, like said the third element, and then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? So we expect to remove 80, right? And it is correct. But what if I want to remove the 30th element? Right, the first element was removed, that's correct. And finally, what if so that was my concern. Right, okay, so yeah, I didn't understand how this thing works, but the program works correctly, which is good. Right, going next. Right, yeah, okay, so not everyone submitted this solution, and the node give us this code. The beginning is here, so we create a new node. What is a node? A node is again a value which we also can modify. It's an integer. The points to a pointed to the next item in the list. There are two methods: display, which obviously just scans the list and fills these values with the current value, right? Then move next, and then we just print it with nice arrows in between. Actually, we can use Unicode code characters, by the way. Right. Then remove. That's the main job, right? So let's first look at this. How do we fill this array? So reverse values 10 to 0. Actually, instead of this, we can always do always use sequences, right? So we can do like this, exactly the same result, right? Right, and then while values. So while we have something, but are we going to while values? While values. So what Raku? So my a is 1, 2, 3, right? While a say, right? So it's a loop which only ends if the last element is 0, right? So something like this: 1, 2, 3, 0, and then while a. So we can now we even can not stop that, right? Or I'm wrong. So I don't understand this piece of code. While right, okay, yeah. Yeah, I was looking for this, but I just didn't see this. All right, so we reduce this array every time in this loop, and after that we get an empty list, right? So we're just popping the value, and right, and we just set the parameters, the attributes of this node. So we see, so you have to create this node twice. I mean, there are two pieces of the code where this code is repeating itself, and right, we are setting the next element to point into the next element, right? We can display it, then we remove. Then there are some calls to remove the element, and let's see what it's doing. So if n is 0, return self next. What is self? Self is basically the head, right? Or is it pointing to the head? Okay, nevertheless. So right, if n is not 0, then while this current element is not nil, so we are moving to the next element, and if the index is the one that we want, then we again skip the neighbor and we return from this function, right? What is self here? Self is this node, so basically we're returning the okay, so we are returning the same element. If it was the head of the list, it will be returned, and if it was the head and n is 0, so we cannot return it. We need to, I don't understand how this n works with like here, but we'll see. Right, and otherwise we return the next element. Wow, just okay. Let's run it. Raku node Raku challenge 2. Run it. Right, so the first thing removes the fifth element. 1 2 3 4 5. 0 1 2 3 4 5. Okay, so we count from 0, which is like not what the task asks, and then we remove the 11th element, but there's no 11. There's not enough elements, so we remove the first one, which is correct, and finally we remove the 0th element. The 0th, what is yeah, I understand why the 0 removes again the first. It's not said in the task, right, if I'm correct, but nevertheless, right, so yeah, it works almost correctly, and let's move to the next one. So I'm right, Raku number 2. So here it is. Okay, so where do we begin? We begin with this n, and again notice these comments, they will appear in the output if you just run the program like this. Raku Simon Proctor Raku 2. Right, so you see, really nice, taking care of the user. Number from the end to remove n if greater blah blah. List of values. All right, so we have to supply our own list. Then linked is from iterator. So we've got this list, and from this so from this we generate the linked list. Let's look at this list node from iterator. So it's a constructor that constructs, that builds the right, linked list. So link list node undefined. Oh my god. Column values. And how do we use this? We use it like this. Right. So for values, so we loop over the values in these values. If start node, what is start node? Start node defined. It's not defined, so it's variable here, right? And yeah, we define it like here. So we create list node if there was nothing there, right, with the first value. Else, if this node was already created, we are using this start node. All right, so it's saved in the node, and basically this is the pointer to the current node, right? We create in the next so again, so we see, so if you're going from the head to the tail of the list, you have to somehow have this constructor called twice, right? And then we just node added next. Let's see what it does. And right, so add next, where is it? Add next is right, just fill in the next field, next attribute. Right, this next just returns this. I wonder why we cannot just put dot here. just because probably we don't want to assign to this, right? So there are other methods like isLast. If the next method the next field is defined, then it's not the last item. Remove next, so it removes the item if is last. No, okay, if it's not last, then we just move these next pointing to the next element, right? Next after next. And then otherwise, if it's last, just it's list node, right? What is the list node then? Okay, I didn't get this. Right, move node. Why do we need to move node? Oh, do we use it? Do we use it, or is it just so? Right, we are not using this, so I believe this is just to make this list node complete class to be used somewhere else. So let's go here. So before we have this list, and you see, so there's like gist method is explicitly called, and we have this one, right? But we can just use say, right? Right. So this is so yeah, just yeah, I see. So it's recursively. Can it be? Is it recursion when you are calling the gist method on the next element, right? So it's not on itself, but yeah, nevertheless, so it should be printing this list separated by arrows. And if n is bigger than linked length, then how do we determine length, by the way? Right, so yeah, just incrementing the counter while moving towards the end of the list, and if it's last, just return this counter, right? Yeah, so see, so there's a separate method to determine if the element is last element, so we don't need to use this while current as we saw it in the previous solution. Right, then if something to delete, right, so we just this is similar to what I had. We are trying to find the element, and as soon as we find it, we just remove this next element. Right, okay, so let's run the program, and I want, okay, Raku summon prop 2, hey, Raku 2, and what do we need? We need n first, like third element, and again 10, 20, 30, 40, 50, 60. Right, 80 should go, yes. So if it's like first element, right, and finally if it's big enough, then the first element should go. Yeah, this works correctly. The only thing I want to try is if I will, so I will do it like this, right, and I want to use this, right, and probably even like that. What happens? Raku 1, so the first element is 3. Okay, let it be like this, right? Okay, so it's not calling, but what if you will do it like this? Right, so inside this, okay, but if I will do it like this, no, okay, so yeah, just bare say can call this gist, right? So gist is defined in class, and it's called if you're printing something like this. Okay, good. Right, so yeah, just take care what method is called if you're using this string interpolation, right, without explicitly calling gist. Right, next, Raku Ulrich. Here it is. There's the node with the value and next pointer. Right. The main function. So enter list of integer. Wow. And right. And we are reading the input lines while you didn't type end. We're filling this array with the integer version of the input and read the next one. and return the array, right? So this is filled, we print this, and then we want to create linked list, and let's look at the linked list class. There are three, okay, so there's node and there's linked list, right? They are separate things. This linked list has the first and last elements. So it's not pure, right? In theory, we don't have to have the last element point, like we don't have to have the pointer to the last element, right? But let's see what's there. And there's this size integer. Alright, so we create this linked list. We just created. Is there any build method? No. We create this, then on this linked list we create list. So we create list here, and we create list using these entered numbers, and this is create list. Where is it? Right, so dollar size, $.size, this field, this attribute is length of this array. The first time true, last, so we create the last node, right? And we take, okay, so we started again from the end of the list. We took the last element in the array, and while there is something in the array, so again this construction, I was stuck with this construction last time. So yeah, we reduce the array by shifting some values. We create new node with this value. Basically, when you create it like this, you immediately fill this value with this value, right? And next, if there's next, so we fill this next pointer, and if array, what does that mean? Because this is while. Okay, so the indentation, actually this is still inside this while. So if we didn't reach the end of the array, we are we are doing this thing again. And if it's first time, current first time false. Okay, so we created a list. Yeah, right. So we create the list, and then if n is big, remove the first, remove the item at position 1, otherwise remove the item as position size minus n plus 1, right? And then to string. So let's look at this to string, right? It returns a string. It takes it starts with the first element. This is inside the linked list class, right? So we start with the first element, and while current item is defined, right, we then move to the next item. So we push the string value of the value to the terms, and then just concatenate it with this arrow. Right, and finally remove at. So the integer k, if k is 1, then we remove the first element. If k is the size of the list, then so then, and finally, if it's something in between, then we do this. Okay, so let's look at the branch where, and I wonder why, like there are 3 ifs here, it should be else if here, right? Or there should be some return here and return there. There's no need to check it 3 times, right? Right. So while we are reaching the k, right? But k is the size. We just wait. What is next? Without any dollar. Again, is here. Current.next, right? But what does this mean? Okay, so a b is the same as a equals a dot b, right? So this one means current is current, right? So yeah, these spaces are allowed, and right, so and this looks like a separate keyword, but basically it looks like it's just this, right? Right, so we just move to the next item, and I was here, and we move further until we meet this K, right? But this is the size basically until we reach the end of the list, right? And it looks like the second branch is repeating the actions, with the only difference that these are in different order, right? So basically it looks like this branch is doing exactly the same as this branch, so we no, except that in the end the next element is nil, and here the next element is the next after next, right? So we remove the element at position K, well, K plus minus 1 depending on how this K is used, right? Raku, only Raku Chat 2, so we have to enter the array. So again, 3 end to end, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, end. Right, so this is my list, linked list, with 80, the third element, removed. Okay, right, maybe I want to run it again, and I want to remove the first element, right? And finally, if I want to remove the 100th element, the first element is removed, right? Okay, so it works. Right, going next, Perl and Raku solutions, and solution from Arne in Raku. It is here, positive integer, an integer where an integer is bigger than 1 or 1, and we take this as input, the only input. Let's move to the beginning of the program. Right, so we create some random lengths value, and for this length we are filling this. So yeah, the elements is just like 1, 2, 3, right? Until this random length. Link element new value is this, right? If current, then next is this one. Otherwise, okay, so this is the solution where this new is called only once, right? Initially we set this head to the first created item, right? Okay, this is clear. Let's look at so we're printing list, obviously. And we remove from end num n and print list again. So let's look at the class. So this class has a value and next, both are rw. Print just, what does it do? Print self value, and if this is next, okay, again this is a kind of recursion, but we're calling this next. We're calling the print list on the next element, not on the current name, right? Really nice recursion. List length is right, so we are beginning at the first element and immediately move to the next one, and we continue moving to the next one until we, well, while we can, and after that we just return the counter. Remove from the end, so the main action in this program. From the end is the n number, length, list length, right? If the element is short enough, then right. Else if n is big enough, then we just remove the okay, so we rewrite the value of the first element and setting it to the value of the second element, right? And right, so we are so yeah, so we kind of take care of using this space filled by the first element, right? And we skip the second element. Ok. Then what actually, if there's only there are only 2 elements. Will this be, yeah, it will be nil, right? And it will be nil here, right? And in the most common case, we start here, and until, right, this number, until this correct position, counting from the end, we move further, and right after that we just set the next pointer pointing to the next of next. Right, so this program expects the number from the end, right? Right. Raku Arna. Raku 2 3. Okay, 2. Now I want 3. Wow. Yeah, this is random lengths, and so okay. So let's look at this. Short solution length is 7. This is the automatically generated list, linked list, and we removed the second element. So what is if I remove the first element? Right, the first element. And what if I remove the 100th element? Right, so the element of the first position was removed. Right, great. Going further, and here it is. So yeah, there's some comment, which let me skip this comment. And right, so here's the node, the class. There's a string with data, Latin word, is required. Wow. And we use this, right? So what does that mean? So is it right? Raku docs. Does it mean that I have to provide it when I'm calling the constructor, or is required attribute trait? So the trait is required will mark the attribute to be filled with the value when the object is instantiated. Failing to do so will result in a runtime error. Right. So when we instantiate so basically when we call the constructor, we have to provide this element. Wow, interesting. I didn't know about that. Is required. And the second one is next. By default it's 0. Well, it's nil. Right. The main program begins here. So natural. What is natural? So it's right. It's positive integers, right? And list size, elements will have values s. What is s? All right, this is s. This is an integer, right? Main. So this obviously is linked list, if I'm correct. This is end, the number of elements to be removed. And okay, so there are more than one. Okay. So this is one variant of the main function. You just provide it with the maximum number, and the list is generated like this. And otherwise, explicit element values. So you have to type it in the command line, right? And we're calling this main lowercase version, and fill it with these items. So building this with linked list. So build. So we are taking these elements, and we append them to the list, which is an instance of the singly linked list class, right? We append it, and then we remove it. So right, we count from the beginning, and right, if it's like if we are too far from the beginning, so if n is bigger than the number of elements, then we stop at the position. Otherwise we use this number. And right, so we move, so we know when to stop. So if we count from the left side, from the beginning of the list, from the head of list, and after that, so yeah, so these two lines move us to the position where we have to remove the item, and we remove this previous, right? So yeah, again we have to keep the previous. Okay, so right, we have to remove the previous item, and it returns something where we can call print. And right, let's look at the class, the single linked list. There are some elements, which is the size. This is the head. Interesting. Wow. So you can I like this. I really like this. So the default value is just the new node. Why not? So why not, indeed. Right. Then append. How do we append an element to the existing list? And we return this list, right? So we create the new node. We save the position of the next, right? No, we move in. Yeah, so right. So to append, so yeah, we have to scan the whole list until we reach the end, and after that we set this node at the end of the list, right? And we count these elements. Why do we need this? Not quite clear. It's the yeah, right. We have to increment. This is the size of the list, which we keep as a separate attribute with this list, right? To remove it, maybe let's look at the print method first. So it prints, so with some title, right, and the number of the elements, right? And if there are some elements, if not, just print empty. This is the string, right? And if there are some elements, then we take head next. Why do we start with next immediately? Not quite clear. So and then we just move next in the while loop, right? So I don't understand why we move to the next element. My node current is head next. This will be some node where we take the data parameter and print it. Okay, then let's look at the remove method. So if preceding is, what is preceding? This one, right? If there is the element next to it, so we move it, we skip it, we skip it by setting the next pointer pointing to the preceding dot next element, right? And we reduce the size, otherwise some error message, and that's it. So yeah, okay. So how do we create? So we can call the function, we can run the program by either type in the list like here or just given the number. So right, Raku Athanasius Raku Ch2. Let's remove the first element and let's have these 10. Not that simple. Right. So this is the automatically generated list, and I want to remove it. It was removed, right? And for example, if I will do it like this, or do I have to do something? I see. So this is named, this is named, and this is just 10, 20, 30, 40, 50, 60, and like 40 is removed, right? Okay, so yeah, it works. Right, going next. And calling crane Raku number 2. Here's the solution. Again, we have some classes, and let's look at this. So okay, so this one, this time this default main function without parameters generates some usage message, and so basically, yeah, we have to run it like this. So location is in, and then the data items. Convert the input command line array into linked list. So right, we create linked list, then we populate from array, and we print this, and we set this $node, unlink the nth node from the end. Right, okay, why? Unlink the nth node from the end. Okay, so, but I thought it's just like setting the head of the array to this variable. Right, then loop. Given node look ahead. Right, look ahead. is, so okay, so we have to understand what the class is doing. So there are two elements, two attributes value in the next, and the method terminate will just cut the list at this position, right, by setting next to nil. Look ahead looks forward and nodes distance in list and returns 1 if the node is not last, and 0 if node is last node, and -1 if list not long enough. Right, so while when, so there are three options. When, so we see, so this when is used without any like given. When, so we return -1. Yeah, basically this code repeats the comment, right? Okay, so looks forward and nodes in list and returns 1 if node is not last node, 0 if it's the last node, right? And -1 if list not long enough, right, if distance is bigger than 0. Okay, and so this is node, but it's not only node, because we are working with linked list, right? But this is right, so yeah, I was looking a bit ahead. So linked list, there's the pointer to the first element and also the last. Populate from array, so we fill the data using these items from the array, and while there are some elements, we'll just create the new node, set the value parameter to the current item and remove it from the list. Then we go to the next. If there's next, what is next defined? What is next? Okay, so right, first time. Right, so this is where we set the $next for the first time in this group, right? And then we set first to the last node. Is it last one? I don't. Yeah, so we see it in the second time. For the second time, right? Arrow print. Just loop. Just a bare loop. You see. So this just repeats. It's an interesting pattern, right? So you can have just a loop and you don't care. You just control it yourself, right, when to stop. So we append the value until basically we have these value, right? And okay, so yeah, finally the Unicode code is used as the separator. Remove next, remove head. So let's start with the simpler one. Remove head has just setting the first to the next, right, which was first to the next of the previously first item. And we cut it here. I don't understand it. Why do we cut the element here if we remove the head? So it's kind of counting from the other side, if I'm correct, right? Right, remove next, return list if there's no next node we return, splices out the next node and relinks around. So node next, right, node next, and cut it again. So I don't understand this terminate. Terminate is just setting this element to nothing, to 0, to nil, to any. Why do you terminate the next node? Well, probably because you remove it, right? Okay, and right, so we looked at every method. My big picture in my head already lost. So yeah, so when, so they just look ahead, and there are, like, remember there are three options: if node is not last, if it's last, or if list is not long enough. And just depending on the result of this function, depending on where this position is in the list, we either remove the head or remove the next. And after that, right, so last look, so boop, we go here, and otherwise we just move to the next item. Okay, right, let's run it. Raku colon Raku Chat2. What do we need? We need just n and array, like say 3. I'm professional typer. Right, so we remove this one, and what if we remove the first one? So 100 should go, and 100 really went away, and now 10 should go. Right. Okay, so that works. Right, and right. So the next solution is this one, right? Alright, so let's look at this solution. So here is the class, and here's the main function. So the main function takes the in, and then we create the linked list, right? New, and then we add some elements. I believe these are the values, right? Then trim in and print it. Right, so let's look at the linked list class. Inside there's another class, node, which is value plus next. Next is actually also a node. This is really good when you specify the type of the right, the link to the next node. Then there's this constructor, which just sets this value to the value from the parameter, and next is nil, and right, this is the node. For the linked list class, there are two attributes on the class linked list, and it's a node pointing to the head, and the count, right, is read only. Wow. Right, how do we set it, by the way? So we set it to 0 initially when we build the list, and the head is nil yet. And the add method, what does it do? So it takes the head, and if we had a head, then while we can move, right, so yeah, we have to add to the end, so we have to scan all the items to find the position where we can append the item, and if there's no head, then we just set it right, and count, we increment the counter, the number of the elements. Right, to print, just scan it, either there's the value or an empty string. And then, yeah, so this construct is a bit like difficult. I believe this is one part, and this is after a comma, just a space, right? Right, end of that. So basically there will be an additional space at the end of the line. Right, okay, so the main method trim integer n, right? So we just, yeah, reflect this to count from the beginning. Right, we take, so if there's no head, right, so yeah, but it's like a simple case, there's no head, there's no list, right? Wait, what I'm, yeah, so this exclamation mark is not a negation, this is just the, yeah, the toggle for the attribute. So if there is a head and I is 0, so if we want to remove basically the first element, right, then we just move the head to the next element, right? And otherwise, if there's yeah, basically what is the condition for this else? So can the head be empty? Probably yes. So we take this head, and while we while we can move, while we can move here, if we found the element, and if there's the next one, then we skip it, right? If there's the next, we put it to the next after next, and otherwise it's nil. Okay, right, so let me run it. Raku Challenges. What do we need? We need something, right? So I believe I was a bit like this, but wait. Right, so we have 5 elements, right? What? Am I doing something wrong? I'm doing definitely something wrong. Right. Right, so there are 5 elements. We want to remove the third. So I'm removing the last one, right, and I'm removing the first one. Right, and the third one, right, 1, 2, 3 is missing. Okay, right. Next, so it was Dar and Javier, Raku number 2. Right, here's the program. It starts with, okay, so we again fill this list. Wait, so we have this range 1 to 6 and we create a list from 1 to 5 in loop. And, okay, so we want to remove the different elements, right, directly in this loop. Let's maybe just run to see what it prints. Javier Raku 2. We don't have to input any numbers. Right, so yeah, if n is 1, the last element, there are these elements in the list, is removed, second, third, blah, blah. And if we reach the end, the first element is removed, and haha, for n is 6, it's wrong, right? So because we have to remove the first element, not the last one. But nevertheless, let's see. So it's basically linked list new, and then create list. We just provide the numbers, then remove the node and display list, right? Which returns the string. Again, there are two classes. Notice that like there's the namespace for this. Linked list node and linked list. The node item contains the value and reference to, it's not a reference in Raku terms, right? And something pointing to the next node. Both can be readable and writable. And there's linked list with the head, with the first element. Okay, so to create a list by the given array, it's a slope parameter, right? So all those 1, 2, 3, 4, 5 will land in a single array. And we just loop over this array and create the node, right? And if there's the previous node, we just populate first and next node, right? So yeah, so I think more or less it's clear what's happening here, right? To remove the node, yeah, the procedure is rather long. Maybe let's look at the display list first. So we set the node variable to the head, and while we can move, we push the value of the current node to the keys array, and then just print this using the nice arrow, right? This one. Right, so okay, so finally remove node. We have to remove node n is copy, so we want to modify it somehow, I believe, right? I don't see where we do modify. Yeah, here. Okay, so head, node pointing to the first element. Then we so total plus plus, we count the number of elements. We have the number of elements, we don't know it yet, so we count it here. Then right, we flip the index. Yeah, so it's a modular operation here, so we'll like loop if the index is 3 and index is 8. Is it the same? Probably not. So yeah, if you yeah, that's why we saw it here, right? So yeah, it should be here, but the modular operator moved us back to the beginning, well, to the end of the list. Right, so while there is a node and we didn't reach n is the number to delete, the index to delete, and if we found this, then if it was the last node, what is the last node? It's not yet known. So right, so we said for the first node we set directly to this second, and last node, what is the last node? Last seen? Or no, last node is here. Yeah, let me skip this algorithm. Just probably this parenthesis is not required. And yeah, the common mistake, potential typo in Raku is just you type 1 question mark and column here, but Raku is smart enough to print a warning. Right, okay, so let's go next. So we've already run this script, right? So let's go to Ren and his solution for this linked list. Yes, so we right, so there's a start range, and you see, so build linked list, so it's colon a function and no parentheses. This is also fine in Raku, right? So let's look here. So it's building linked list, given the values, given the copy of values. We start with the last one, and right, the tail, the last element, we create this node with an obvious pair of attributes. Then we put it to the array. Notice that this is last. Wait, last is the value, right? Why is it here in place? So last is the value. Even here we have the confirmation. So node's value, why we are, so yeah, the index of the element is its value, right? If I'm correct, this is what I see here. Sorry. So again, we're just forced to have the list like 1, 2, 3, 4, 5, if I'm correct. Okay, then for wow. Oh, so for values from the first till the end, basically for all the values except the first one, right? Keys reverse. So I believe if we call keys on an array, we got indexes, right? My A is ABC. Right, so we've got indices, and we scan the array from its end till its second element, and this is the I, the index of this element. We take the value and create the node with that, right? And also, right, we already have something in this node, so we can take it and put the next, and finally we fill it with this newly created node. And after that, we just create linked list pointing to the first element, right? Okay, so linked list new. So yeah, note there's no comment about this. Linked list, there's head, there's method gist to just print it, arrow separated, and there's make array. We didn't use it yet, right? Right, so we go back here. So we built a linked list and saved it in the linked list. Why underscore? Why not dash like here? So yeah, see, so in function names there are dashes, in variable names underscores. Right, so linked list, make an array. I kind of understand why. But let's see. So we create an array, and so there's one value in this array from the head, right? And while the next pointer is defined, so while we can move, we push the next value of the next node to the array and then return the array. So basically it just returns us an array based for the given linked list. We get the array containing the values, right? Right. Then start range, new range. If n is more than, so yeah, so if n is bigger than the length of the array, we just remove the first one from the new range. That's really strange solution. And otherwise, if n is not that big, we just delete. Oh wow, yeah. Yeah, so personally I find this syntax, adverb syntax, a bit weird, So you're calling some action on some element. Well, maybe, yeah, maybe that's fine, but why not just use method call in this case or something else? Nevertheless, right. So we just locate the element that we want to delete and remove it. If you remove, for example, A1, so this is about letter B, delete, right? Right, so we get this, but inside this, you see there's the hole, so the element is not completely removed. And that's why we need to grab it and remove everything which is not defined, right? So if defined, we pass it the new range, and then we build linked list based. So in short, this algorithm creates a linked list, then it creates an array, then it removes an element from an array, and then it built a new linked list based on this modified array. Right. All right. Raku, Lauren, Raku, chat 2, say 3. Right, the number 3, like a 1, is removed, and if it's like 10, the first element is removed. Right, so this is the linked list, a true linked list. This is a linked list, but in between there are arrays involved. Right. Okay, Mohammed, Raku 2. Yes, so just immediately, okay, so there's default. Oh wow. So yeah, so I believe Mohammed is going to pass the string in the position and create linked list based on this string, then trim position, trim. Oh yeah, nice. The name, the choice of the method name is interesting. Show again and say. Show and say, probably like show remove gives you the string, right? Where is it? Let me find it. This, right? So it returns a string, and then we print this. Right. Okay. So create linked list based on the string representation of this list. So list. What we do, we remove all the spaces, then we split by arrows, and then we create the node for the first item, and then we loop over the list, and we take the element out of the list, convert it to an integer, and create a new node, and then yeah, tail.p. What is p is node, and tail is, oh my god. So tail is the node, right? So we set it to node. What is then p? Where is the node? Node p. It's pointer, right? P stands for pointer, I believe. Its value, it's pointing to the next, right? So we set next to the node, and then we set the node self to the same node. Okay, I didn't get that. Right. Okay, and after that, so we create linked list. Then we so after this, what we get the node, right? So this returns you the object of the node class, right? And then we call the trim method on this node. So there's no direct like separate item, separate class for the linked list itself. So there's only node, and you can call different methods on the node. So like you can show, but it shows the whole list, right? Yeah, so here we move to the next item, and we append the value, and then we print all of them. So right, so yeah, if you call show on an item on a node, you will just work with the list indirectly. And the same happens to trim, I believe, right? So we trim at position, we remove the element at position, and if it's invalid, it is invalid if it's not a number, an integer number. All right, then so we think we are the tail, and some count, while there is the next element. We move and we count, and as soon as we found the position, if the position is more than right, so what is the position? The position is right, and this count is like this position was 3 and count initially was 1. So what happens? So this branch is called right, but how do we increment? Yeah, so we increment count. So in the first few iterations we only work with this branch, and then as soon as we reach the position, as soon as count reaches the position, if there is node, still remove current node by making the parent of current node parent of previous node. Okay, and otherwise just return the so this is a parent, this is not next, this is not a pointer, it's a parent of the previous node. What is this be? Right, okay, so we removed it, I believe. Raku Mohammed, Raku 2, and I need, what do I need? I need nothing right here. Right, so the second element is removed, but for example I want to remove the first one. Position is 1, right, and position is say 4, and position is 5, and position is 55. Right, okay, so this solution works. So the only thing is what does P mean? Okay, next. Here it is. Right, wow, it's big. Okay, so main, we can add the debug flag if we want. $D, where is it? So it's a global variable which is false. But this is about debugging, so we can completely ignore it at the moment, right? So then there's linked list, new linked list, and we push. So is this push a method that was defined in this class? Right, actually there are more than one pushes. Right, so we add again, so the list is 1, 2, 3, 4, 5, and for 1, 2, 3, 4, 6 we are trying to remove this nth element. Say values. Right, so we flip the index, and this is if n is bigger than this is the size of the array, then some iterate, I believe. So we pop an element at the position I, at this position. So pop, I think it should scan, right? Yeah, so it scans. Well, yeah, so it moves this iterator this number of times, right? Right, so we where was I? So we pop at this position. So this is the basically the thing pointing to the element to be removed, and then push this at this. So like kind of you replace this, or what is it? So does this push mean just insert here? Because we don't have to push, right? So I can believe that we can push and take the next element and put it in place of the existing one. Right, okay, so let's look at the classes. So there's linked list class, it's here, so it's the forward declaration, right? Trusts, oh my god, so what does that mean? So I think it's a kind of thing for accessing the items, right? To allow one class to access the private method of another class, use the trait trust. A forward declaration of the trusted class may be required. Right, so we have this forward declaration here, and so this class trusts this class. Yeah, so yeah, now I see. So we have some private methods, and I'm just wondering where are they used. So they should be like, okay, yeah, you see, so this one is called, in another class to which we trust. Okay, so there's value, there's next, there's no question here. If it's last, so if it's not defined, if the next element of the last element is not defined, then it is last element. Set next, right, so you got this another item, and you set the next attribute of the current item to this another one. Then you reset next. Okay, just remove any in links and replace next. Then there's another one, so the previous one is the next is another, and return the previous one. Okay, so yeah, we replace the next one and we return the previous version. Right, so you see, so I was right. So for this push that we saw somewhere here, for this push we actually replacing the node. Right, let's look at the linked list. So there's the core, what is core, and there's separator, Unicode character, begin returns an iterator. Yeah, what is an iter? Is it? Right, this was an iter. Right. Wait. Then. So basically, it's a node, right? Yeah. Then when we create it, we set the core to the do not remove value. So it's the first the core. I don't know what this core means here. And to count. So this loop from it's C++. So you increment the count while this defined iterator, which is the next, right? While there is something next, we can increment the count, and then we get the length of the linked list. Okay, then we have 1, 2, 3 versions of push and 2 versions of pop, and return another iterator which has moved forward. But let me leave it as homework. But maybe what was commenting is like this one is kind of a dot but calls a private method, right? But what is interesting that we know that this set next is a private method of the class iter, right? And here this class is also mentioned. So yeah, because these classes, they are not like parent and child, they're just 2 independent classes, and one class trusts another one. So yeah, we have to know where we are trying to which method we are trying to call in which class, right? The same is here. Right, so there's another method for push, and another method push, which does something. So what does it do? So that at is copy where returns in it, right? And there are 2 pop versions. So pop if there's a node, and if there's a position, right? So if it's a node, are we going to find it, or I don't know. Right, okay, but let me run it. Raku to Raku, and right, I don't need to enter anything. Right, so yeah, it's similar to what we had somewhere like here, right? It's 1, 0, 5, n is 1, and this is removed. This is removed, and then if like 4, this is removed. The second element is removed. If it's 5 or if it's 6, the first element is removed. Right. So the program prints the correct result. Right. And finally, actually not finally, there's one element skipped. There's no solution to here, but we skipped Ben, and I thought it was the most difficult, but actually probably it's not the most difficult code. So no, it's quite simple. Right, and then let's start. So again, this forward declaration of the class, why do we need? Because the main function is here. So in unit submain, interesting. So there's unit submain, and there are also there's also a pair of curly braces. Then we don't need unit, I believe, right? Okay, so so yeah, basically this. Let's see what that is. It's kind of slurpy, but it's something special. Raku documentation, right? So yeah, I was there already. It's where is it? Right, slurpy conventions. This can be achieved by using a slurper with a plus or plus at instead of star star, if you wish to match this look and feel. Any iterable argument was broken. Okay, so it's some kind of slurper argument XS. It's not Perl's XS, I believe. It's where all of them, right, are defined integers. The second argument of this list is, it's not factorial, it's, what is it? Is it required parameter, right? But this is already, right? Yeah, so it's required, and it's named, and it's scalar, and it's defined, and it's integer, and it's positive, right? So once again, so there's this required n positive integer, and there's a list where, yeah, I wonder how does it work. So basically, n, I have to like type dash n equals something, and these are just space separated, and all of them are integers, right? Okay, say say do with. So with, we know that it also sets the topic, and what we do here. Okay, so linked list. Right, so we have to look at the definition. So linked list and this construction. This construction, what is it? It is the typed role, right? It means that this type, yeah, it goes here and here. But basically, this syntax is well, it's not the same as in C++, but basically the idea is exactly the same as in the in templates there. So these typed roles, we need it if we instantiate. I'm not sure that I'm using correct term in terms of Raku, but nevertheless, so if we are using this, then we've got this linked list for defined integers, and then this value is defined integer, and then this. So this is, what is it? This is the current role, if I'm correct, right? So it's linked list underscore t. Next, why is it underscore? So let me. Okay, so what I've got here is, so I will skip this, I will remove this. So let me understand, if I'm typing this, then what happens here? So here this t is replaced with this one, right? This one is replaced with this one is replaced with this one, right? So for this value, we know that it should be defined integer and is built bind, no idea. And this one is basically this, right? If I'm correct. Is it like this, or Yeah, I don't understand this. I don't understand that. I kind of understand the idea, but I don't understand the syntax. Okay, then. Okay, so inside this linked list, and what is built? What is built? Is built attribute trait, right? So it's built false. The trait allows setting up a private attribute during object construction. Right. Okay, so there are from lists. So there are a few methods that generate a linked list from a list, I believe, right? And we see, so prota is usually it's a useful thing, which kind of defines the interface for all the other multi versions of this method. No, this is definitely for your homework. And self bless. So bless, yeah, it's something from Perl 5. Haha. Right. Then there's this new, and actually new is different from build capital, right? Okay, so we've got this. So we take this input XS. We create a linked list like this. Then it topicalizes, and this has become a list, and we just delete. Why do we need this? Right. Right, so this is really difficult code, which I mostly don't understand. Then, so there are again a few multi-delete, actually really multi. So it deletes, for example, like we've got this index and turns the role, basically it turns the linked list. Role also with this, right? Or not? Maybe this one is the same as this one, right? Yeah, you have to read the documentation if you want to use this in Raku. So delete. Same with again. Well, at least from this solution, there are a few words which we probably never heard about. Same with calls current candidate again, right? So this is about multi-versions, and these multi-versions, they are called candidates as well. Calls current candidate again with arguments provided by users, and returns the return value of the new instance of current candidate. Right, so we are calling the same candidate again with different, right? So if we have some integer which is less than 0, then we call it, well, nice, in interesting construction. So we just call it again and we correct the argument. And here, if the number is bigger than the length, then we just call it again with the correct length. Right, and mtk, what is that? Whatever code, there's some code. Okay, right. And finally there's gist also. And how do we use gist? We are using probably it here. Say we'll use this gist, and it takes the gist form, basically the string of the value, the string representation of the value, and then with the, so we typicalize next, and we call gist next, and this is a string, and we append it and return the gist. Gist is a string. Right, so basically it again kind of recursively calls the gist method, but not in itself, but in the next element, right? So here is the next of the current, and this next calls gist for the next element, and that next element calls gist for the next after that next. Right, okay, let me just run this. what's in the input. In the input we have 10, 20, 30, 40, 50, 60, and I want to remove number 3. No, wait, I need to do it like this, right? Not like that, like this. And we count 1, 2, right? And if I remove the first element, 60 should go, and I've remove hundredths element, 10 should go. Right, okay, right, okay, so we're done with this task. So it was about removing the element from the linked list, and right, so there were a lot of different solutions. Most of them used a simple node, but a number of solutions created some linked list class and manipulated with that. But nevertheless, okay, so it was a really long thing and it was difficult. There are a few really difficult solutions which you probably have to consult the documentation to understand those solutions. Something like the same width, and what did we see, like plus at in the signature of the function. Wow, weird character. Yeah, okay, so nevertheless, so yeah, I hope you enjoyed it. I hope it was not that difficult, or at least it was entertaining. So yeah, see you next time. See you. Bye.